Hello friends, today's question. A horizontal circular platform of radius 0.5 meter and mass 0.5 kg is free to rotate about its axis. Two massless spring toy guns, each carrying a steel ball of mass 0.05 kg, are attached to the platform at a distance 0.25 from the center on its either side along its diameter. Each gun simultaneously fires the ball horizontally and perpendicular to the diameter in opposite direction. After leaving the platform, the balls have a horizontal speed of 9 meters per second with respect to ground. The rotational speed of the platform in radian per second after the ball leaves the platform is. So there is a slight correction in the question. It says that velocity is 9 meters per second should be given perpendicular to the diameter. Okay, so this was a slight correction. So in this case, we are going to use the conservation of angular momentum. So let us first of all find out the initial angular momentum. Initial angular momentum. Now, initially, both the platform and the balls are, you can say, stationary, or they are at rest. So therefore, the initial angular momentum will be equal to 0. Therefore, we can say initially the platform and the balls are at rest. Therefore, the initial angular momentum is 0. So we can write it as L initial is equal to 0. Now we can find out the final angular momentum. So final angular momentum will be because of the platform which is going to move, as well as because of the balls which are being fired. Okay, so let us first of all find out the angular momentum because of the balls, rather. Angular momentum of the balls. So we have two balls. So you can say after the balls are fired, each ball is going to contribute in the angular momentum. After balls are fired, each ball contributes to the angular momentum. So therefore, let us find out the angular momentum of one ball, and then we can find out the angular momentum of the second ball. Okay, we can say angular momentum of single ball. Let us get written as L ball of only one ball, so which will be equal to mv multiplied by r. And the second ball is fired in the opposite direction to the first ball. Okay. So we can say, since the balls are moving in opposite direction, their total angular momentum will be. So you can say the angular momentum of total angular momentum of both the balls will be equal to angular momentum of ball 1 minus angular momentum of ball second ball. Okay, and mass, the velocity and r is same for both, so we can write this will be equal to mvr, and this is minus of minus mvr, okay, because both are traveling in opposite direction. So this gets 2mvr. And we can find out the moment of inertia of the platform about its axis, because it is only going to rotate about our axis. So we can say moment of inertia of the platform about its axis. Let us say this is I platform, and it will be equal to half mr square. So therefore we can find out its angular momentum if it is rotating about with the angular frequency of omega. We can say angular momentum of the platform with angular velocity as omega. So we can say angular momentum of platform will be equal to moment of inertia of platform multiplied by its angular velocity. So now conservation of angular momentum. Conservation of angular momentum. We can say total angular momentum before firing the ball should be equal to total angular momentum after firing the balls. Total angular momentum before firing the balls will be equal to total angular momentum after firing the balls. So before firing the ball is our L initial. So we can say this L initial will be equal to angular momentum of total because of the balls plus angular momentum of the platform. So L initial was equal to 0, so this is 0, and if your ball is 2 mvr, plus, and we have half mr square multiplied by omega. So we can write this as half mr square, omega will be equal to minus of 2 mvr, or we can say that our omega will be equal to minus 2 mvr divided by half mr square. Now simply substitute the value. Okay, here the negative sign doesn't have much of the significance. We are only thinking about the magnitude. The negative sign simply indicates that its direction will be opposite. That is, the rotation of the platform will be opposite to the direction in which the bullets will be fired. We substitute the value, it comes omega is equal to minus, and this is our 2, and we have here 0.05 multiplied by velocity, that is given as 9, and we have the platform 0.25, and here we have half, and its mass is given as 0.45, and radius is 0.5 whole square. So here omega will be equal to minus of 4 radian per second. Okay. So negative means it will be moving in opposite direction to which the bullets are being fired, because bullet fired will be generating the angular velocity in one direction. So in order to conserve, the table will be rotating in opposite direction. So that is the only significance of this minus. Okay. So this is the rotational speed of the platform. This is the rotational speed of the platform. So this completes the question. Thank you.